All right. Thank you, everyone, for joining the session today. Thank you for the conference organizer. I'm excited to be here. This is my second time presenting in the user conference. Last time was about Docker. This time it's a more MLOps topic. So I'm excited to be here. We have 1 hour to cover about deployment and monitoring of ML pipelines with open source and free tools. So we can get started. The goal is more to talk today about design and less about coding, given that we want to use the 1 hour. So without further ado, I can start with a quick introduction about myself. So I'm a senior manager at Apple. I'm not representing today anything related to my work at Apple or going to talk about my work. On my day-to-day work, I'm doing a lot of forecasting, MLOps. I'm also open source contributor. I wrote a few R packages related to time series. And I'm author of a book about time series, and currently in the process of working on 2 books related to Docker for data science and forecasting at scale. I'm writing a lot of tutorials about Docker, R, and MLOps. You can find it on my GitHub page and on Medium. And recently I released a course about deployment of pipelines with GitHub Actions for R and Python. Today we're going to focus about the interaction between forecasting, MLOps, and open source. We're going to talk about deployment of MLOps, of machine learning pipelines, data pipelines with GitHub Actions and Docker using open source tools and free tools. All the materials for this talk is available on the following repo. So it's a use R 2024-pipeline-workshop. I need to commit some stuff, so it's still like some of the stuff that is work in progress, but the pipelines are already there running and active. So I will start with a quick poll. If you can comment on the chat, and I need to figure out how I can check the chat, but are you familiar with the following tools that we're going to talk during the presentation? One is Docker. Second one is GitHub Actions. And third, which I'm sure most people are familiar, Quarto. And last is MLflow. So let's see if I can see the chat. I think that's the way to do it in Zoom. If you can type, are you familiar with those tools? It would be great. And I can, while people are responding, I can quickly kind of like walk through the tools we are using. Starting with Docker. So Docker is a CI/CD tool for containers, build, shift, and manage containers. Is a great tool to when you're working with a multiple environment. And I will dive into a little more details in the coming slides. GitHub Actions is a GitHub feature that enable schedule and automate workflow. For data science application, this is a great tool if you want to automate the data pipelines, open source project. If you are using a deployment, you want to set unit test and so on. So this is a great tool. Quarto, I think most people are probably familiar with Quarto, is the successor of R Markdown. Is a great tool for documentation. I like to use it when I'm deploy works in GitHub Actions because you can run scripts but having a visual representative of your code is nicer, and it's easy to debug when things are broken or you get results that are not as you expected. Last, but not least, is MLflow. MLflow is a MLOps tool for tracking experiments. So if you're running machine learning models and you want to track, if you're doing some research, you're testing multiple models, and you want to identify to do a comparison between the results. So MLflow is where you set the tracking, and it enables you to review the results. Let me jump. I see that the chat is not working, so I can. Okay. So I assume, I see there are some technical issues with the chat. Okay, now it's working. But my assumption is that probably most folks here know what is Docker, but not necessarily have some experience. And not maybe familiar with MLflow. So I will try to explain a little bit throughout this presentation, what are the use case of those tools and how they are playing in this deployment. And now I see the chat is working. Thank you for enabling it. Before getting started, I would say that there are alternative tools. So anything that I'm presenting here, there are probably for each tool, there is something else they can use. So like I love to use GitHub Actions and Docker. I used to use those tools, so it's very convenient, but there are other tools out there. So for Docker, there are open source alternatives like Podman and other open source, but Podman is probably the main one. For GitHub, so there is the GitLab and other orchestration tools that are as free tier, which we're going to use today. And MLflow is the reason I'm using it because I use the Python version, so it's easy for me also to pivot to the R version. But the POSIT released recently their own tool that equivalent to MLflow, which is Vetiver, if I pronounce it correctly, which is also probably will work better if you're using tidy models and the R ecosystem. So there are other tools. I think what you need to take from this is the philosophy of deployment rather the tools. And you should probably use whatever works for you best. All right. So the agenda for today will start with motivation, how I got to deploy pipelines with the GitHub Actions and Docker. We'll talk a little bit about the workflow. And then most of the time, we will talk about the design of a pipeline. And we'll leave some time for questions. If there are any questions throughout the presentation, feel free to ask. We'll try to, I see the chat open, and I see that most people, I see now a response from most people that are familiar mainly with Quarto. But if you have any questions, you can raise your hand. James here will try, if I don't see people raise hands, so James, please let me know and try to answer question while we're going as opposed to wait to the end. So feel free to tackle me with any question while we're going. So let's jump for motivation. And it all started, and I see some questions, so feel free to, before I continue, Bianca and Bruno.
Bianca and Bruno, your microphones should be enabled if you want to ask your questions.
Okay, or you can write on the chat. So, going back to February 2020, probably familiar with what happened at that time. This is where the pandemic, the beginning of the pandemic, COVID-19. I went to see the headlines in CNN. The CNN has a nice archive, and I captured some of the headlines at that time. And beginning of February 2020, the headlines were focused on China. China was where it started, but the majority of the news were still like if in the US, where the fun stuff. There was the Super Bowl, what Jennifer Lopez were doing the Super Bowl performance, and Demi Lovato performance. The same kindergarten, the politic kindergartens, who spoke with who, or who is not speaking with who. And I saw this headline, which was for me, it was very funny when someone from the government come and say, no reason for panic. The next thing that when the first cases showed in the US was a lot of panic, which is expected. That's a normal human behavior. And the next thing that you saw is people stocking toilet papers in Costco, and that's it's a kind of like a funny kind of like start of not funny, but that's how the pandemic started. And for me, I saw it as opportunity when I saw the Johns Hopkins data dashboard that they released, and I saw it as opportunity to package the data. And there are many data packages that's what I love in R, that people taking data sets and packages. But the difference between this is that was the live data. So a few days I was able to find the source, and a few days after it was in CRAN as a package. It's called coronavirus. That it was before they rebrand the rebrand, I'm probably not the right phrase, but they changed the label to COVID-19. So we're really at the beginning of the pandemic. I created this package, and the idea was to create a tidy format for the data and make the data accessible using the Johns Hopkins data. And the process was that I had a script that every night I ran it to pull the data from the Johns Hopkins repository. At the beginning, it was more unknown than known, and I didn't realize how long this pandemic is going to be there. So it was, for first few days, was okay to run manual script, but then problems start to show up when doing manual stuff. There are a lot of data issues that came with it, the data integrity, a lot of issues with refreshing. I realized that I cannot continue with this manual process, and I looked for a way to automate, and I promise this is the last Will Ferrell GIF. And this is where I discovered GitHub Actions. It was, I think at the time, GitHub released this feature. And immediately after I started to use it, I started at the beginning to use it without Docker, and I converged to use it with Docker because of a variety of reasons. So what is, the combination of those tools, how does it work? So as I mentioned before, GitHub Action is a CI/CD tool, and I use it as a scheduler, but there is more beyond, software engineers use it to run builds and test. But essentially, my main use case was a scheduler. You can set a cron job and run some script. So that answered my requirements about setting automation. And Docker, I started to use Docker on this project in the beginning, it's just the process is when you are running a workflow, you're getting a machine, and you need to set, either you set your environment from scratch, and a lot of things could go wrong when you are setting it from scratch, and having a container that you test your code is much more safe way to deploy. So it was really a quick turn on to move to Docker in this deployment. So Docker in a nutshell, what is Docker and why we want to use it? So if you have any type of code, if you're using R, Python, Julia, or any other programming language, you want to create environment. If you are shifting your code to a remote environment, you want to develop inside a container and shift your code with this container. So essentially think about it as you are having your machine and you send your machine to the remote server to use the same environment. And that's the idea of Docker. And one of the things that is nice about Docker is that if you tested your code locally, the same test should pass on the remote environment. And if something failed on the remote environment, you can reproduce it on your local environment, assuming you're running the same image. I would say that there are some caveats for reproducibility with Docker. So there is no perfect tool or one tool, but generally it's very robust, and it's the main industry, it's main tool in the industry for reproducibility and deployment of code. I think a lot of things changed when Apple released the M1, which impact, and I think until then Intel was very dominant, the CPU, and CPU it's something that can impact your deployment, and there are some solutions, but essentially if you're developing in a Mac with Apple Silicon, so you're using ARM processor, and for example, the machines in GitHub Actions are using Intel-based CPU. So if you want to deploy, if you deploy your build that you build on ARM CPU, it might not work on Intel, if the machine running with Intel. So that's the only caveat that I'm familiar with. But other than that, it's very robust, and there are many solutions for Intel multi-CPU architecture. So with that, what can you build with GitHub Actions and Docker? So there is the classical use case of CI/CD and automation. You want to automate some process. You have open source project or a personal project, and you want to run some script at at some time, so you can set a scheduler. The second thing is it's very helpful when you're doing code development and testing. So if you're familiar, if you're a package developer and you are running RCMD, so you can deploy a unit test and essentially RCMD. So whenever you are committing any change in your repository, or you have a pull request, it will run a RCMD, and you can create a badge, and it will send you email if something fails. So that's a nice testing that you can add for your open source project. And there are the fun stuff, like if you have a data automation and you want to deploy a dashboard. I used to build a Flex dashboard. Now there is Quarto dashboard. So it's fairly flexible. You can automate data, render a Quarto dashboard or document, and deploy it in GitHub Pages. And of course, there are machine learning applications. So if you want to deploy some model and run it, refresh the data, run the model, refresh the model, in this case forecasting, on some cadence, so you can also set this automation. So there are plenty of application. I think you can use your creativity, but you can do a lot of stuff. Another thing that this is not many people I feel familiar, but you can deploy application on Hugging Face spaces, including Shiny dashboards, Quarto docs, and so on. And you require Docker, so you can set automation to build like a Shiny app or some Quarto doc and deploy it in Hugging Face to host it. So all the tools that I'm going to talk today, they are open, either open source or free tool to use. I will just caveat that Docker is a free tool, but it requires license if you are in an enterprise setting. Also, the GitHub Actions is free. If you're a GitHub user, it's free. There is a free tier up to a certain limit. I would say that I'm using it for, I think now, close to 5 years, and I never reached the limit. So it's very powerful to run. Or if you're a free user, there's a lot of things you can do before you hit the the free tier limits. I would also caveat about the limitation of those tools. I will start with it's not secure. So anything that you deploy on GitHub Action or in the workflow that we're going to talk today, it's by default it's not secure. You can build a security layer, but by default, if you are moving data or running some jobs, you should be aware that the free tier is open and anyone can see whatever you're running. Compute power, so there's a limit of how much you can get on a free tier. So of course you can run basic regression, and I tested like with running basic machine learning models. So it can, with whatever you can run on your local machine with a single or CPU with a limited amount of RAM can run there. But you should be aware that if you have some heavy, if you're running some inference and require more intense resources, so this is where you may get into some limitation and the job might fail. Availability, so the free tier, it's GitHub will prioritize jobs for the paid users. So within the hour, if you are trying to get, I think the limitation is if you're trying to get at the minute level, if you have cron job that you're trying to run at the minute level, so it might not run exactly at the minute that you are setting. For example, if you are trying to run it every hour, 10 minutes after the hour on an hourly basis, it might run after 30 minutes or after 5 minutes. But there is a dependency on the machine's availability, and the free tiers at the hourly level might not be, you want not get the workflow run at the exact minute that you are setting it. If you're running it beyond the hourly, it will be fine, but again, like there is a prioritization to paid users. Last but not least, data storage. So if you are required to store data, you should be aware that there is a limitation. Technically, you should not, if you have a big files, you should not store it in a repository. And I was thinking about showing how to use some free tiers on some cloud providers, but I feel like there is some risk there that most of the cloud providers, you put your credit card and it's free tier until you are exceeding your whatever is available on the free tier, and then your card is start to charge. So I didn't want to show something like this, but this is another option. And generally, like if you have a application that require to store big data, then you should find the storage solution. So with that, let's see example. Let's talk about how we can deploy and monitor pipelines with GitHub Actions. So starting with the workflow. So technically, any pipeline or data science project will follow the following 5 steps, starting with scope. A clear scope will save you a lot of time down the road. So always start with defining what are your goals, what you're trying to do. And based on this, you can define the requirements. The requirements could be what type of compute you need, what type of resources, what environment you need to build. And again, like a clear scope will enable you to define a clear requirements. And once you have the requirements, you can start with the design process. I like to take, on a paper, a pencil and paper, and scratch something about what are the steps that I want to build. It's enabling me to kind of like think about the milestones that I need to generate the process and build, in this case, the pipeline. Once we have a clear design, we can then build the functions that we need to support the different components of the pipeline. And the last step is the deployment. Now, maybe there are, other small steps in between, but those are the main 5 steps for building pipeline. I would say that the first 4 steps are the most intense. It's about 90% of the time. In some cases, you will spend on those 4 steps. And again, it might change how much you spend between the design and the build, or setting the environment. But most of the time, this is where you spend. The deployment is fairly simple. Once you have image and you have a code that you ran on your local machine and it's working, you just need to set a YAML file to execute it on the remote and test it. So let's if taking those steps and see like a real example. So let's say that we want to generate a pipeline to forecast electricity demand in California. So let's start with scope. We want to forecast the hourly demand for electricity in California by sub-region. In California, there are 4 providers or sub-regions: Pacific Gas and Electric, Southern California, Edison, San Diego, Gas and Electric, and Valley Electric Association. So essentially, we want to get the data. That's the first thing. And then we want to generate the forecast, and the data is refreshed, is hourly, so we can try to pull to check if data is available every hour, and update if we find the data to update the pipeline. And then we want to generate the forecast for the next 24 hours every 24 hours. So essentially, let's say midnight, we want to, once we get the point that we passed the midnight, we want to generate a new forecast for the next 24 hours. And this is how the data looks like. There are 4 series, and you can see it's hourly, so it's very dense data. And it's starting from 2019. So if this is what we want to do, we need to think about requirements. So start with, we need to set environment, a Docker image. We want to use GitHub Action, in this case, as our orchestration tool. We need to build a data pipeline to keep the data up to date. And we need to build ML pipeline to generate the forecast, refresh the forecast. Last but not least, we want to set a dashboard that you can review the forecast, the data. You can, any components to monitor the data and so on. So we can use, in this case, Quarto dashboard and deploy it on GitHub Pages. So this is like the basic requirements that we want for this pipeline. And for the data, so we're going to use the following data source, EIA API, which is available through the Energy Information Administration, which is a US federal bureau under the Bureau of Statistics that focus on energy. It's a great website for time series. The reason I got and found this API, it's provide close to or over 1 million time series, different time series related to the energy field in the US, from pricing, consumption, pollution, and so on. It's a great resource, and they have a great API. So in this case, you can see that if you go to the dashboard of the API, you can filter what type of data you're looking for. You get the header of the query, and you can use it to pull the data. So this is the data source. It's a straightforward. It's free. It's open. We're going to use it to pull the data. So once we have the requirements, we can start go to the design process. So design, we start with kind of like build to design, scratch all the components of the pipeline. And this is the overall pipeline design, and we're going to spend the next few minutes to break down the different components and see how it's fit in the process. So let's start. The first thing is setting the environment. So we, across all the components, we will use the same environment. You want to be consistent, or we want to make sure that you're using a single environment, that your code, if you're running locally or on the remote, using the same environment, and you test your code in the same image. So we'll start by building image. So the way that I'm my deployment or my Docker philosophy when I'm using R is I'm first building a general image. I'm using VS Code because of the VS Code has a great integration. If you are using R and Docker, probably you want to use VS Code, as it has a built-in integration with the Docker, with the dev containers extension. So I'm setting a base image with the requirements for VS Code and R. So for example, I'm here, you can see, I don't know if you can see, but the arguments, the first 3 arguments is the version of the R. I can customize it. I'm setting the R, I'm setting all the dependencies, and that's my baseline image. I'm on mute. Someone mentioned I'm mute. I know if you can. Okay. All right, I think you can hear me. Okay, thank you. So the once I set a base image, it's easier to set the specific user, like the specific requirement for the project, and this is the image I build for the project. Now, it's very. I assume that for folks that are not familiar with Docker, it might sound a little bit gibberish at this point, but essentially Docker, what I'm showing now on the screen is the Docker file, which is the manifest of the build, which I'm providing a set of instructions how to build. So the second image that I'm building is the project that I'm going to use, and this is the image we're going to use on the deployment. And you can see that one thing to notice, because of I'm using a ARM64 CPU, and GitHub is using AMD 64. So I have the image that I'm using on my local machine, and I have a similar image that for the deployment. So I'm building the same image twice with different CPU architecture. And this image is very simple. I'm importing the base image. I'm then running R script that install the requirement libraries. And I have this JSON file that with all my settings for this project. And you can see here, like the first 5 libraries are time series related, Lubridate for working with the time and date objects. Before I started, I wasn't sure if I'm going to use the Fibel, so I installed also Fibel, but eventually I end up using model time. So you have here also both libraries for time series forecasting, and then I'm using point length for data validation, MLflow for tracking the experiment, JSON Lite to read JSON files, EIA API to query data from the API, and GT just when I'm using tables in the Quarto docs to use it for tables. So you see, like that's kind of like the settings, but technically you can clone the repo and modify it for your use cases, and it's a straightforward if you know what you're doing. But essentially, the way it's orchestrated, the way it's organized, that you can clone it, fork it, and technically modify the dependencies and set your own environment, with some caveats that you may run into some issues if in my base image I installed the dependencies, all the compilers that required for those libraries. You might use some unique libraries that require some other compiler that was not installed, and you need to figure out and update the compilers. But generally, that should cover most of the compilers. So once we set the environment, that's the first milestone. Setting an environment is working with the data. So we're using here the EIA API and using the package. I created this package when I started to use the API a few years ago, and it's straightforward to send GET requests. If we have some time at the end, I can show a little bit like how to use the dashboard to extract the to search for time series, and then how to pass it to the functions to pull data. But essentially, that's just a set of functions that enable you to send GET requests to the API. You need to set a user, and you get a passcode to authenticate. The API is a Rust, a full Rust or Rust API, which mean that you need to authenticate on any call. The next components, we will run locally 2 components. One is backfill function. So you don't want to, when you are initiate the pipeline, you don't want to do it on GitHub Actions. You want to run it locally. You want to monitor it. You want to make sure everything runs properly. So I'm running it locally, and it's also it's more intense. So think about that. I think there is about 200,000 observations per series. If you're assuming you're pulling the 6 years of data, it's hourly, so it could be intense to do it on GitHub Actions. So I'm doing it locally. The second component we run locally is backtesting, which is training the time series models. So I'm running a bunch of time series models, and I will explain a little more details in the next slide. But essentially, I'm doing some cross validation of multiple time series models and select for each series the model that perform best, and that's what we're going to use on the deployment. So this is intense in terms of compute, and there's no reason to run it on GitHub Actions. So those 2 components are we run locally. The next component is the pipeline itself, the deployment on GitHub Actions, which will include the container and then a set of functions that will enable us to refresh the data. And the last component is the dashboard. So we want to communicate the results, render a Quarto dashboard, and deploy it on GitHub Pages. The first component of the pipeline is the JSON, which is a setting file that I'm using with all the parameters that we need to use in the pipeline. So for example, we are going to pull 4 series. And so we define it in the JSON file. We define, for example, the backtesting, how many partitions I want to use, how many cores I want to allocate, the ML flow path, and so on. And the type of models I'm going to test. The reason I'm using a JSON file with all the settings, it makes this pipeline portable. So imagine that tomorrow you want to, we're doing now California, but let's say tomorrow you want to run the same pipeline for the New York region. The New York region have, I believe, like around 7 or 8 different series. So you just change the series over here. The IDs, or update IDs, and you can run the same code, and it will generate everything. Should generate anything because it's all code based, and that's the only place you need to change the pipeline. So it's very useful when you have a setting file. And this is how, for example, I'm reading the setting files and parsing from JSON the information and use it in our. So let's break down the backfill function. So as I mentioned, it's enable us to initiate the pipeline, or whenever something breaks in the pipeline, you want to restart the pipeline, you run this function and reset the pipeline. I'm using Quarto doc. Again, it's very useful, or for me, it's very efficient to use Quarto doc to run everything. I can then review the results. I have all the tests that I'm running, and I can visually see the results of the test, as opposed to some code that's running and give you some log, which you need. You can use it, but I feel like it's more friendly. One thing that you can use is Point Blank. It's a great library for data validation. You can plug it and define the test that you want to use. I also created some additional helper functions to create metadata, to log metadata, and append whenever the pipeline is running. So you want to set your own function depending on your use case to enable you to run the pipeline. Some helps think about the helper functions. The next component, which is probably the fun part, is the backtesting. So backtesting essentially is the time series equivalent to machine learning cross validation. The idea is that you're testing a time series model. You're splitting your data into multiple training and testing partitions, and you train your models on your training partitions and evaluate the performance on the testing partition where the model didn't see, and score the results. And then once you score the results, you can decide, based on some error criteria, and this is how the log look like on ML flow. You can compare the performance of each model and select the one that perform best based on some error criteria. At the end of this process, because we have 4 time series, we track which model perform best, select the model that you want to deploy, you log it, and then on the pipeline, it will use the model that you select, and it will fetch it from the JSON file that I showed before. So the main component is the pipeline. And this is what's going to run on GitHub Actions. So starting with the data. So we're going to have 2 components. One is we refresh the data, and generate forecasts. So we save those files as CSV files and we store it on GitHub. And then we collect metadata and logs, and we store those logs as CSV files. So those are the two types of data we're going to use during this process. And again, we're going to use a data refresh function. That the goal of the function is to go on whenever the workflow is triggered by GitHub action to check if new data is available on the API, and if so, to refresh the data, append it to the normalized table, and update the metadata. And similarly, like the forecast refresh is triggered by some criteria, in this case, every 24 hours to refresh. And there is also a scoring function that scores the models that we generated in the past, and you can track the performance and monitor the accuracy. So this is how the log would look like. And the reason that we want to create logs is if something breaks, it's easy to go and see. You set a unit test and you can evaluate if you see that the forecast didn't refresh for a couple of days. So you can go and try to, based on the unit tests, try to evaluate what happened, and if the unit tests are sufficient, you will get the picture. If not, you will have to maybe do some additional testing. But it's very useful having a log, and when you want to deploy monitoring process, this is what you're going to consume as your input. So you end up that you're going to have those, in this case, those 5 files. The first file is the best models for each series that we're going to use in the deployment, the data, the forecast, those are the normalized, and the logs for the forecast, where we score the models. Every time we generate a forecast, we score it and we can track it, and the logs of the data. I would say that you can, in a ideal world, if I had more time, I would also deploy this on MLflow and fully track it on MLflow. But it's also something, it's a nice to have to fully deploy it on MLflow. The last thing I want to say about CSV file, not the best practice, as I mentioned. So if your files are small, yes, you can use it on your repo, but you always start with small files, and they might over time get big, and I would say that's not the best practice. So evaluate if the data that you're using should be in GitHub or should be in a database or some storage before starting the process. Those refresh functions, I'm using the Quarto, again, from the same reason. It's visualized, you can track it, you can deploy it in GitHub Pages and review it. We have 20 more minutes, so I will go fast. I'll leave some time for question. The deployment. So, once you have all those functions, this is where you're going to set a YAML file with your manifest for the GitHub action. So this is how the file will look like. It's a YAML file. All the GitHub deployments are stored under on your repository under .github and a folder workflows, and then you set your YAML file. Once you set it, your GitHub will pick it up and will execute it. And here we set a cron job to run on an hourly basis. We set the environment, so we ask GitHub Actions to provide us with a Ubuntu machine, and we mount the image that we created. And you can see here it's AMD 64 because of the CPU type. So the first step I'm using, because I want to use the repo and I want to write back to the repo. So I'm using a function of GitHub GitHub Actions called checkout, which enable you to, during the run of the workflow, to pull your repo, and as you are in your local machine, like you are inside the repository, and write back. And then the last step is to run a script that orchestrates all the Quarto docs that refresh the data, refresh the forecast, and render the dashboard, deploy it on GitHub Pages. And you can see that I'm using secrets that you can store with GitHub as a service, GitHub Actions as a service to store secrets. So for the API key, I'm using in my GitHub username and email. You can use it also as a variable name, environment variable, but I just set it as a secret, so you can pull it during the work and use safely the API key. And the bash script that I'm running, this is how the bash script look. So it's straightforward, starting by clean up the old Quarto output, render the refresh function, the Quarto doc, copy the output of the docs. So if I want to deploy it on the GitHub Pages, I need to store it in doc. There is another step that if there was a new data and there are commits to make, so it will render also the dashboard. So it will render, there is index.quarto doc that it will clean up the old file, re-render it, move it to the docs folder, and then that's how GitHub Page will update the new dashboard and commit the changes and deploy it. The last component is the dashboard. It's straightforward. You can visualize anything that is, you can imagine. Here I just put a simple, like the data. I have an example where still I need to commit, but like where you can see the forecast, the metadata, and the tracking KPIs that you want to track. So I will pause here. I will skip because we are less than 8 minutes. I want to leave some room for questions. So I will end up with what else you can do. So this is just an example of what I did, but you can do much more beyond. So think about, you can add some bots that you can send messages when you run a pipeline. So think about you have some job that you want to track stock prices, and you want to run it every hour and send some information to some Slack channel, to a Telegram bot or Mastodon or any other application that support API that you can communicate, and you can also use it. So the amount of stuff you can do is really, it's up to the user imagination. I will end up with some best practices that I recommend for starting is know the tool's limitation. You cannot run every jobs. Use setting files like the JSON file, on your design. Try to think, what if I need to modify the pipeline in the future to a different, in this case, time series, and you want to be able to, the pipeline be flexible, that you just set your setting file, you modify it, and you can use it in for different series. Unit tests, super important. Don't skip it. Interactive documentation, we talked about. My preferred way to deploy pipelines using, instead of script, it's nicer and friendly. Last is something we didn't talk, is GitHub templates. If you have a pipelines that you think that is you can use it in other use cases, GitHub has a feature that you can create a template. You create like your own template, and then you can just use it and modify the settings according to your use cases. So conclusion, GitHub Actions enable you to do great automation. It's free. It has a free tier that you can use. Great use case for open source projects. Also, if you have like a light project, personal project, you want to automate data, it's it's a great tool to use. Use Docker for your environment. That's my recommendation. There are other alternatives. Not saying that they are less, they're just not as robust as Docker. I would just say that last thing is not enterprise ready. So take into account that, if don't try to, use it in your enterprise work as an alternative for enterprise tools. It's great, but there is a limitation. There is license limitation and compute limitation. But if you are starting with pipelines, that's how I started, and was great learning experience. So I will pause here and see if there are any questions. So I see there is a question from Fabian. What are solutions for doing this with the sensitive data? So I would say the first thing is that GitHub Actions or any other alternatives like GitHub Lab, they have the enterprise version where there are more secure settings that you can use. Obviously, that's something that you also, I'm not a security expert, but on the deployment, if you're deploying some tool, you need to make sure that the application that you are connecting during the connection that is secure. So that's more like a DevOps questions. But I would say that when you're moving to the enterprise tools, they offer the security level. I hope this has answered the question. Any other questions? I can maybe quickly go and show the other question. So this is how you can get in touch. But all the code is available over here. So this is the repository for this workshop. You can see that the dashboard is here. One thing to notice that you can see like the last time it got refreshed is today, 7 o'clock UTC time. You can see that there was outage on the weekend, and some data that's on the API, some data is not available, but that's in the upper stream, like not something related to the pipeline. That's where you want. The reason that I noticed that there is some issues when I run the backfill function is that I have a set of unit tests that were triggered and given this notification. Can see maybe the backfill function. So this is how the rendered backfill function. You can see the log. It gives you kind of like there are some unit tests, and you see it's failed because there were missing values, and it gives you like also some. I set it like there is a comment, so give you indication there was missing values. And this is where when you are running the pipelines, you need a decision how you handle those pipeline, the missing values on the backfill, and then on the automation, if there are missing values, I stop the process and log it and prevent it to happen. I think we are on time. Let's see if there are any other questions. Okay. This is the API dashboard where you can, filter the data that you want. Here I'm, filtering for the California data. You can choose any other data. Yeah, that's the pipeline. So I will pause here. We're on the hour. Happy to take another question if there are. If not, we can end over here. Thank you for everybody that joined. Thank you for the organizers for the invite. Thank you, James. Thank you, Emily, for helping with the workshop. And if there are no other questions, so I think we can hand over here. Thank you.
Cool. Thank you very much, Rami.
Thanks. Enjoy the rest of the conference.